One way to think about the gases in our atmosphere is to classify them as either permanent or variable. Nitrogen and oxygen are permanent gases because their concentrations have been pretty much steady for millions of years, while water vapor is a variable gas because its concentration varies from day to day and place to place. The concentration of another variable gas, carbon dioxide, CO2, has been flirting with a milestone this past week. For the first time in human history, its concentration is approaching 400 parts per million, meaning 400 CO2 molecules in every 1 million air molecules. That's not much compared to other gases, but don't let that fool you. Carbon dioxide is a primary controller of Earth's temperature via the greenhouse effect, and thus a gas that climate scientists worry about a lot when it comes to global warming. This landmark milestone, more symbolic than scientifically meaningful, is taken at the world's oldest continuous carbon dioxide monitoring station, the gold standard for CO2 measuring, near the peak of Mauna Loa in Hawaii at 11,000 feet elevation, where air has traversed thousands of miles of ocean and is extremely clean. The upward march of CO2 is best seen on the iconic Keeling curve, named for scientist Charles Keeling, who started measuring CO2 in 1958, when levels were around 315 parts per million. The increase seen here is the result of human activities, primarily the burning of coal, oil, and natural gas. Now, back in the late 1950s, the rate of CO2 increase was less than 1 part per million per year, but the climb is steeper now. Over the last decade, it's been about 2 parts per million per year. The story is the same all over the world, though the southern hemisphere lags the northern because most CO2 emissions occur in the north, and it takes a few years for the gas to mix globally. The current rise in atmospheric CO2 started around 1800 with the Industrial Revolution. Before then, levels were steady right around 280 parts per million. So there's been about a 40% increase over the last 200 years. These older CO2 measurements come from studying the air in bubbles trapped in ice cores, drilled from Antarctica and Greenland, essentially fossilized air. The deepest core is 2 miles long and takes us back almost 1 million years. Samples of ancient air from this lengthy core show that CO2 levels fluctuated naturally between about 180 and 280 parts per million during the last 800,000 years. So the current CO2 level is easily the highest in at least that long. To finish up, let me go back to the Keeling curve and explain the wiggles superimposed on the overall trend of increasing CO2. Those wiggles show the natural annual cycle of carbon dioxide. As plants green up in northern hemisphere spring, more CO2 gets removed from the air, so levels decrease a bit from around May to October. Then as plants go dormant for the cold season, they take less CO2 from the air and levels go back up, though a little higher than the year before because of the human contribution. The long-term trend of increasing CO2 shows no sign of slowing down, let alone stopping, barring an immediate worldwide switch away from burning fossil fuels, a fundamental change which is very unlikely anytime soon. Paul Knight is back next with the extended forecast.